Hey everyone, my name is Ioannidis and I'm a PhD student at the University of Pennsylvania. And today I would like to talk to you about formally verified compilers for functional programming languages. I will be using the cockproof assistant as the host language and the simplytype lambda calculus as the guest language. Building formally verified compilers for functional programming languages is not an easy problem. We can make it simpler by reusing a lot of the features of the host language to implement the guest language. This will be a recurring idea in this presentation. The first instance of this idea is generalized algebraic data types, or GDTs. GDTs use the type checker of the host language to ensure only well-typed terms of the guest language can be created. Another instance is higher-order abstract syntax. PHOAS is a syntax representation that reuses the binders of the host language, and in that way, we don't have to define capture-avoiding substitution, we can simply use the substitution mechanism of Galena. One obstacle in using higher-order abstract syntax in Galena is the strict positivity requirement. Galena programs correspond to proof objects. In that sense, we cannot have a non-terminating program as that would mean a non-terminating proof object, which could be a proof of any statement. Instead, we will work around the strict positivity requirement by keeping the binder type polymorphic. This is a trick called parametric higher-order abstract syntax introduced by Adam Chipala in 2008. This works well with GDTs, and this allows us to write the syntax of our STLC finally like this. So what is the next logical step in this idea of using the host language to implement features of the guest language? How about evaluation? Olivier Danvy has showed in his work that normalization by evaluation can be implemented with a type class, which is defined structurally on the types of the embedded language. That type class defines two methods, reify and reflect. Reify takes a host language term into the guest language, and reflect takes a guest language term into the host language. Together, they define an isomorphism between host language and guest language, which is strongly normalizing, as long as Galena is strongly normalizing, which it is. We can prove, for example, that all first-order functions, that is, functions with primitive types as arguments, all normalize to a head normal form. In fact, the proof is a single line of Coq tactics. To sum up, we have shown that using the host language features to implement features of the guest language is almost always a good idea. Because Galena is now formally verified, we feel confident using Galena features to implement formally verified features in our own language. Thank you very much for your attention.